This is 7-7 part 2, and we're going to be talking about how do we multiply when we have pretty much more than just binomials. And I'm going to actually show you kind of 3 different ways that we can do this, and like I told you in class today, that you can kind of pick the one that makes the most sense to you. So the first one is to pretty much distribute several times. So what this looks like is I'm going to take the 5x here, and I'm going to multiply it by each part of this trinomial. So when I do that, I have 5x times 2x squared, and I'm going to write this all out just so you can kind of see what I'm doing. And then I have 5x times 10x, and I have 5x times negative 6. Then let me take and do the same thing with the 3. I'm going to multiply it by each part of the trinomial. So then I have 3 times 2x squared, 3 times 10x, and 3 times negative 6. So then if I multiply each of these, okay, 5x times 2x squared is 10x cubed. 5x times 10x is 50x squared. 5x times negative 6 is negative 30x. Then 3 times 2x squared, that's 6x squared. 3 times 10x is 30x. And 3 times negative 6 is negative 18. Then the next thing I want to do is combine like terms. So 10x cubed is the only x cubed I have. Then I have 50x squared and 6x squared. So that gives me 56x squared. I have minus 30x plus 30x, so those actually cancel each other out. And then I have my minus 18. So my answer to that problem would be 10x cubed plus 56x squared minus 18. So that's how I do it using the distributive property. This is the method that I use when I'm doing it, but it's not necessarily the best one or the one that works the best for you. Now the next thing I can do is use what we call the rectangle model. And you'll notice that this is the same problem that we did before. But we're going to set it up a little differently. So what I do is I make a rectangle, and I put each polynomial that I have, one on the side and one on the top. And what I'll do is I'll take and do 5x times 2x squared, so that gives me 10x cubed. And then I'm going to do 5x times 10x, that's 50x. 5x times negative 6, negative 30x. Then 3 times 2x squared is 6x squared. 3 times 10x is 30x. So this should be squared there. And then 3 times negative 6 is negative 18. So then I have essentially what I had before. Now I got to combine my like terms. So 10x cubed. Then I got 50x squared and 6x squared, so that's 56x squared. 30x minus 30x, and then minus 18. So I end up at the same place with the rectangle model. You might notice here that it seems a little bit shorter. It kind of is, except for you got to draw the rectangle and do all that sort of stuff. So I don't know if it takes more or less time, but there's another method you could use. Now a third method we call the vertical method, and this is kind of the same process we use when we're actually just multiplying numbers together. So what I'm going to do here is line them up like this, and now I'm going to take the 3 and multiply it by everything. So 3 times 6 is negative 18, 3 times 10x is 30x, 3 times 2x squared is 6x squared. Same here, 5x times negative 6 is negative 30x. And I'm going to line this up here. Actually, let me start this one over so that it looks better. I kind of wrote it backwards there. So let's start over. 3 times negative 6, negative 18. I'm going to write that here. That makes more sense. 3 times 10x is 30x. 3 times 2x squared is 6x squared. Okay, then 5x times, I got my space holder here, right? Just like multiplication. So 5x times negative 6 is negative 30x. 5x times 10x is 50x squared. Notice I'm lining up my like terms here. And then 5x times 2x squared is 10x cubed. So then, just like in vertical multiplication, I'm just going to add these up. So I got 10x cubed plus 56x squared. Those are going to cancel each other out, and then I got minus 18. Okay? Sorry about the mix-up there. It's easier if you write it this way. The other way would work, but it's more confusing. Okay? So there's kind of the vertical multiplication method that you can use. Alright, so those are three possible ways to multiply a binomial times a trinomial. And you could do it with trinomial times trinomial. Pretty much anything bigger than binomial times binomial, you'll want to use one of these methods on. Now, they'll also show up kind of in the form of story problems for us here. The width of a rectangular prism is 3 feet less than the height. So the width, we'll call that W, 3 feet less than the height. So here's my height minus 3 feet less than that. The length of the prism is 4 feet more than the height. So that would be height plus 4. Okay? Write a polynomial that represents the area of the base of the prism. Now, I don't know how much work we've done with three-dimensional figures. I think we talked about them some last year. But, so we have a rectangular prism here. That means it has a rectangle as its base. So the base would be the width times the length would be the area of the base, right? Of a rectangle. So, in order to find the area here, we're going to do h minus 3 times h plus 4. Now this is a binomial times a binomial, so I can use our favorite method, FOIL. So first is h times h, which is h squared. Outside is 4 times h, so 4h. Inside, negative 3 times h, so negative 3h. And last, negative 3 times 4 is negative 12. And then I can combine my middle terms. 4h minus 3h is 1h. So I have h squared plus h minus 12 for the area of the base of the prism. So you will run into some story problems on your homework as well, and they're just trying to get you again to kind of combine geometric stuff with our algebraic stuff that we're doing right now. Okay, so that's 7.7 part 2. Let me know tomorrow if you need extra examples.